Record. Okay, let's go.
Hi. So me and Wayfang have worked at the project by the topic name, building a recommender systems using graph neural networks. Let's go jump in it. Let's start with the introduction. First of all, we have recommendation systems. We are surrounded by recommendation systems. Their basic purpose being recommending stuff. So, for example, if you go to a website, let's go for an Amazon as an example. If you're looking for something, for example, you're trying to buy shoes. Next time you visit, you might get some recommendations about the kind of shoes you already have checked out. Similarly, if you were to think about Netflix, what does it do? It sees what you like. It understands the kind of videos, the movies you have seen, and it would recommend you based on that. And they are quite fairly accurate if you were to notice. They do match our interests. That is the job of recommendation system, and that has been possible because of technologies like machine learning. Let's so here what we do is we have been focusing on three different algorithms to build a recommender system for movies to recommend movies. Let's go to the next slide. Right here, first one is popular based recommendation system, which is the simplest one. What it does is it collects the customer data for all of the customers in the base in the pool, and it would see which things are popular. In our case, with the movies, it would see which pop movies are popular with the customers, and it would recommend based on that. So, for example, we have a new release, Avatar: Way of the Water. If everyone's watching that, there's a good chance that you are being recommended the same thing. Merits for that, it doesn't require any customer feedback. We can, it doesn't have the cold start problem. You can just have it up and running whenever you start. Now, the next one is collaborative filtering, which is again a similar approach. But in this case, what happens is there is an intersection between interests. So, for example, me and VFAC, we would have different search history with different kind of movies we have been watching. Now, what our machine algorithm would do is go through our common interest and recommend us based on that. So, for example, if we have some similar interest, it might recommend the movies that I have been watching to Weifang and vice versa. Now, let's jump to the next slide. Now, what we have done is there are different collaborative uh, recommender systems, methodologies. In our case, I'm sorry.
It's fine. Keep going.
In our case, we have gone through utilizing the metric factorization method, which we will touch upon during the demos. That's it. I'll have Weifang will continue the presentation from here. There you go, Weifang.
All right. So in the third one, which the one we learn the most is the GNNs. So we use the graph neural network we learn from this class to apply on the recommended system we design. So graph neural networks is allow us to easily to work with users and items. So because each node in the graph can represent a users or a items. So if we provide a connection between nodes and nodes, that means the users and the items can have the connections. When based on these connections, we can provide recommendations to the users. So each node is the users, and we can just create a graph that links nodes to nodes. So which means the users to items. Each user has the links to another nodes, which means the users link to another items. So the used graph neural networks can help us to provide the most optimal recommendation for the users. So this is the gradient list. So is similar to the adjacency adjacent matrix. So we can look at the let's go back to the matrix factorizations. When we do the matrix factorizations, we fill out the mixing values. We fill out the rating for the users on that items, right? On the coordinate list, we just store every value. So we store the row, the columns, and the values. So we store the row, for example, for this case, 3, 4, and 5. So we store the in each array. So we just create 3 arrays to store the positions of each values. So we can use these arrays, as I mentioned, to train, to apply to the GNNs, graph neural network, to train the models. And because the computer doesn't understand what the nodes are, we need to transform the nodes to a vector format so the computer can easily understand to how to calculate. So GNN, what we use is the GCN. This is the very powerful graph neural networks models. What the main purpose of these models is to convert everything, to convert the nodes, everything to embeddings. And then we can use this embedding to perform the predictions for the users. So we can just go to the collapse and get the deeper understanding. All right.
Okay. I can start with the introduction here. So my focus here was doing the general EDA and focusing on the first two algorithms, that being the popularity based and collaborative filtering. So as you can see, we did the initial um, data setup, downloading the files itself. Okay, there's a slide back. So after that, we are loading the data frame, checking basically doing an exploratory data analysis right here till this, and give me one sec. Let's jump right into the popularity based part. Here, it's quite simple. We just had to merge the genres first of all to clear the data set for very quickly, see the ratings, the total ratings, and we grouped up I'm sorry, we grouped the ratings together, found out the average, and based on that, we are calculating which movies are popular. So right here, if we were to see, one second,
Yeah,
these are
this
the
is,
popular movies
yes.
which you would recommend based on. Now, jumping into collaborative filtering based. Here, right here. Okay. So if we did the initial setup, um, and we kept on finding out the ratings for different movies based on user. We create a matrix right here between the movies and the user title, with having the ratings right here in the matrix column cells, replacing the NaNs with zero rating. But obviously, the none values represent that the user hasn't watched the movie. After that, we use the cosine similarity function from scikit-learn and find out the cosine similarity for the movies between the user and the movies. And utilizing that, we have a small function right here. One second. We have a function right here which recommends based on the movie you give. So when we recommend when we give it a movie, what it does it would find the index for the movie and use the matrix we had created earlier to find the best recommendations based on that movie name. In this case, like if we were to use movie name X-Men 2000, which is a good movie by the way, we would get the recommendation based on that. X-Men 2, X-Men United, same genre, Spider-Man, Matrix, Star Wars. They are the same thing, in my opinion. And I'll let Frank take away from here.
Yeah. So we also try different approach. So the last one is to use GNNs. So so the GNNs we find is the so first of all, so we set up a threshold, right? So each user's rate the movies we play score, so 1 to 5. So we need to set up a threshold. So we need to select like what's the good rating for user to consider that movie is their preferred movie. So if the user rate a movie 1 point, or that means the user doesn't like the movie. If the user rate the movie 5 point, that means the user likes the movie. So I set up a risk. So if the recommend system try to recommend a movies for the users, try to recommend items for the users, we need to recommend the items the users like, not the users hate. So we need to set up the threshold that above 3 point, above 3 points. So we set the threshold 3.5. So set the threshold above 3, so we can, so that items indicate those the users like. So in the first, so we in here we find out that the most case, the most threshold, the most ratings are from 3 to 5. So I think it's bad. I think it's a great threshold to select. And first of all, I mentioned we need to convert the we need to convert the data to COO formats. So just like the adjacent matrix, so we convert it to the matrix format. So we store after that we can have the arrays, as I mentioned. So we can have 2 arrays. So we can have arrays to store the rows, arrays to store the columns, just like right. I mentioned here. Okay. So here's we use the array to store rows, array to store the columns, and we split the data to 80% training, testing, and validation. But we are not going to use validation for hyperparameter tuning in this case. So that's just for the testing purpose. So and we can see there's, after we split the data, and we can get from the users nodes and the items node, the combinations is about 10,000 nodes in the graph. So what we do is try to, so we know the users is the node, right, in the graph, and the items also is a nodes. So if we can find out if whether there's a whether is this a connection or not in these two nodes, between these two nodes. If we can find a connection between these two nodes, that indicates the users like these items. So we can provide recommendation based on this connection, right? So what we do is just to do the link prediction. As we learn, just put to do the edge prediction in the graph. So we convert it to make sure it's to the we convert it to the tensor. So that we can use the apply to the library we're going to use in the later. So we first of all, we select a batch from the data set. So we're not going to use all the data once. We're gonna batch our data one by one. So we implement the algorithm. So this is the algorithm I find from this article. So this is the algorithm. So as I mentioned, the large GCN, the main purpose of this model is to convert everything to embeddings so that the network can use this to compute predictions, to perform predictions for the users. This is the set of the all neighbors nodes and the items. So we use 1 divided by and times each layers of the embeddings. What is the layers? Layer is just the consideration between how many nodes you want. So we would do in the GNNs we would do is the for message passing and aggregations, right? So how many nodes you consider? If you consider a lot of nodes, you need to the message passing will be very big, right? So that's the how many layers. That's how many layers you determine indicates how many message passing, how many how deep is the nodes between how many neighbor nodes you select to compute the embeddings. So in these models we compute the embeddings, get every neighbor's embeddings, and we use 1 divided by the embeddings. We start and we put in we compute them the mean of these embeddings. So I set this to 3 layers, which is very good amounts, the nodes I select. So if you want to get a very more connections between items and user, you can change to more higher. And then we calculate the loss. Loss just the we use Bayesian personalized ranking. So this is to calculate the predicted values and the true values. So you can see it's the true value, but you can to find the differences. This is the you can change this. You can see this as a bias. We need to plus some hyperparameters. So and we can just we can just sum up the every layers of the nodes and the users. And this is the formula found from this article. So interest-bearing payments, and to see how the models performs, we need to use the matrix to evaluate the models. So one of the we use record, and to predict the true value, true positives, and another one is positions. We also use some another advanced algorithms. These algorithms are also found from the articles. This is the use to predict the top K recommendation. So if this is the top movies we recommend, that means this is the true. This is the values will be very close together. So the highest from 0 to 1, the highest is not the So the 0 indicates not the close, that the closest, that the 1 is not the closest. So get the recourse, and this is the define function, and we can see the graph and the form and our variations. So I trained the network with 20 epochs. So it took about 2 hours without GPUs. So this is the performance. So we can see as the iteration increase, the loss is going to decrease. This is the validations data set as I mentioned for the testing purpose. So this the loss is getting low, decrease. For the record, also the Google it stops at the about 30% up here. At the 30%, the records getting stable. We test the data sets. We evaluate the data sets we evaluate the test data sets. So we got the positions about 0.4. So so you might say it's not good, but in the reality, this is very hard to perform recommendation for the users in reality, because users can click everywhere, so can just look at every items. Some items they might like, some items they might not like, and some users just click on some items just without any reason. So the system doesn't know what items the users like, so just what they do, just collect those items and provide recommendations. And I think you can see in the reality, when you go to those very famous websites like Amazon's, if you type in the items you want to look at it, oftentimes you might find someone you like, but oftentimes it just lists all the items that are similar to the target, to the ideal items you want to look at, right? Because the recommendation just use all the information, collect and provide recommendations to the users. So we'll also try to predict we can see the predictions. So if the user's ID is 30, so we can predict these items. All right. So let's go to the summary. So for the popular base, so the popular base recommendation system is very good for to decide a top list to solve some problems such as cold start problems. And then the second one's corroborative filtering is to find the interactions between users and items. This is very popular right now. So even the graph model networks, we also use graph filtering. So it's called graph corroborating filtering recommendation system. I think in the futures, this will be more and more popular. So the system will combine those two, will be like hybrid hybrid recommended system. And the last one is the one we learned in this remaining focus is graph neural networks. So this one is what I mentioned is just to enhance corroborative filtering. So because we applied the matrix factorizations into the networks, so the network can high tune the parameters, so then I can tuning the weights, can update the weights every training, so it will come up with the optimal values. for the table. So I think that's all we have. All right. Thank you.
Thank you for the presentation. Very fine.
Okay. Use how to stop record?
I'll just close the meeting.